So heterodyne means mixing. Heterodyne means mixing. So super heterodyne receiver is the commercial AM receiver. Before super heterodyne receiver, we have TRF receiver, tuned radio frequency receiver. So first of all, we see what is the concept of reception, AM signal reception. So when we want to receive some signal, okay, we should have a system receiver with the proper Q factor. That Q factor depends on broadcasting frequency. That means center frequency of the communication divided by what is the bandwidth of the particular operator, bandwidth of the each channel. So what happens in reality, okay, in general, say for example, AM system, in AM system, the range is from 550 kilohertz to 1650 kilohertz is the range of the AM broadcasting. The maximum frequency of the AM system baseband signal or message signal is 5 kilohertz. So the bandwidth of each operator will be, bandwidth of each channel will be 2 times of FM, that is 10 kilohertz. So now each station will be centered at some frequency. Each station will be centered at some frequency. So depending on that, F0 will vary, but BW, that bandwidth is always constant. Bandwidth is always constant. Now say for example, I am choosing one station at 900 or one station at 600 kilohertz, then another station at 1200 kilohertz. Now what will happen? Anyway, bandwidth is fixed. Say for this 600 kilohertz, I need a receiver with a quality factor of 600K divided by 10K, that is 60. Okay, for the reception of 1200 kilohertz signal, I need a quality factor of 120. So that means I need to have different types of filter. When the incoming broadcasting frequency is different, I should have different filter, okay, to allow that corresponding channel. So that is the major problem in the ordinary receiver. So that what we will do here, okay, in case of super heterodyne receiver, what we will do, entire whatever may be the input signal, usually the input signal in case of AM, it will be from 550 kilohertz to 1650 kilohertz. Whatever may be the input signal, we will be converting into some constant frequency. We will be down converting into some constant frequency, that is 455 kilohertz. This frequency we will call it as IF frequency, intermediate frequency. This frequency we will call it as a IF frequency. Then after that, we will do the demodulation. So whatever may be the incoming broadcasting frequency, we will convert it into some constant frequency, that is 455 kilohertz. Now the demodulation circuit is a simple constant circuit, simple constant filter. Okay, in the previous case, depending on the input signal frequency or broadcasting frequency, you need to change the filter design, or you need to have a different receiver. But now here, what we are doing, first we are down converting into some constant frequency. So whatever may be the input signal, that will be down converted into some constant frequency. That frequency we are calling it as a intermediate frequency. After that, we will do the demodulation. So now the advantage here is only single receiver is enough. Single demodulator is enough. So that is the main advantage of super heterodyne receiver. Again, in the name itself, it indicates that heterodyne operation. That means some kind of mixer operation. So before going into the actual discussion, we will see what is the concept of mixer. When I have a mixer, the mixer will have two input signal, two input and one output. Say this is the frequency 1 and then frequency 2. Then what will be the output of the mixer at any point of time? There are 4 different output possible. Okay, either I may get F1 plus F2 or F1 minus F2, F2 minus F1, or minus F1 minus F2. But ultimately we will take only positive frequencies. So, but you need to know the mixer output will have 4 different combination. Okay, at any point of time, mixer will have 2 input with a different frequency. At the output, it can produce all these four combination. At the output, it can produce all these four combinations. Suppose if I need f1 plus f2, if I need f1 plus f2, then I have to put a proper band pass filter here. I have to put the corresponding band pass filter. Or otherwise, if you need f1 minus f2, then you put a corresponding band pass filter, then you will get only f1 minus f2. So depending on the situation, so mostly the mixer will be followed by the band pass filter. Mixer will be followed by the band pass filter. Okay. So now we will, okay, we can choose the desired signal, either f1 plus f2 or f1 minus f2. So mainly we should know the mixer output can have the four different combination. Then I will draw the actual diagram of the super heterodyne receiver, SHR receiver. RF amplifier, mixer, IF amplifier, then detector or demodulator, then audio amplifier, then speaker, finally speaker. So the mixer will have two input. One comes from the RF amplifier output and another one is the local oscillator, LO, local oscillator, and RF amplifier will get the signal from the RF antenna. Okay, so this is the block diagram of the super heterodyne receiver. Or SHR, super heterodyne receiver. So now the broadcasting frequency or station frequency I am writing as FS. FS means incoming frequency or station frequency or broadcasting frequency, anything is okay. And then this one is the local oscillator frequency. Now the output is FLO plus or minus FS. Okay, in general FLO plus or minus FS, but plus or minus you have to put here also. Quickly we will see, okay, what will be the actual output here. Then IF amplifier, detector, audio amplifier, then finally it goes to the speaker. Okay. So now this RF amplifier consists of band pass filter that is hidden. Okay, RF amplifier consists of band pass filter. The RF amplifier உள்ளே என்ன இருக்கும், band pass filter இருக்கும். அவங்க எதுவும் போடல, but that is the hidden one. The RF amplifier will consist of band pass filter. So now what is the job of this band pass filter? Okay, in general, okay, in the free space we will have many frequency. Now the job of this band pass filter is to allow only the frequency that is in the range of 550k to 1650 kilohertz. The RF amplifier நம்மளுக்கு என்ன பண்ணனும், 550 kilohertz ல இருந்து 1650 kilohertz மட்டும் தான் என்ன பண்ணனும், அலோவ் பண்ணனும். ஏதா அதுதான் வந்து AM உடைய broadcasting range. Okay, so here FS means, what is FS? FS, I can say carrier frequency or station frequency or broadcasting frequency. So இது போல எந்த நேம்ல வேணாலும் அவங்க சொல்லலாம். FS. So நம்மளுடைய aim என்ன, whatever may be the input signal வந்து 550 ல இருந்து 1650 குள்ள எந்த சிக்னல் வேணாலும் இருக்கலாம். But ultimately the mixer has to produce only one value, okay, that is 455 kilohertz. That is 455 kilohertz. 455 kilohertz. Why? Because that is the intermediate frequency. That is the intermediate frequency. ஏற்கனவே சொல்லியிருந்தோம், எந்த சிக்னலா இருந்தாலும் நம்ம ஒரு கான்ஸ்டன்ட் ஃப்ரீக்வன்சி கன்வெர்ட் பண்றோம். அந்த கான்ஸ்டன்ட் ஃப்ரீக்வன்சி வேல்யூ வந்து என்னது, டவுன் கன்வர்ஷன். Again, conversion is also down conversion. This is the down conversion. Down convert பண்றோம். அப்படி பண்ணும்பொழுது 455 kilohertz க்கு தான் பண்ணணும். So now for analysis purpose, just I am assuming. So I am assuming the local oscillator frequency FLO is greater than Fs. I am just assuming. Okay. இது போல தான் இருக்கணும்னு அவசியம் கிடையாது. It can be anything also. But I am just assuming always the local oscillator frequency is greater than Fs. It can be less than Fs also. Just assumption தான். இப்போ ஒரு some simple case எடுக்கிறேன். Now the incoming frequency I am taking as 1200 kilohertz. Incoming என்ன frequency வருது, 1200. அது இந்த ரேஞ்சுக்குள்ள இருக்குதான்னு பார்க்கணும். இருக்குது. அப்ப கண்டிப்பா RF amplifier இருக்கிற band pass filter allow பண்ணும், amplify பண்ணும், அது mixerக்கு input-ஆ வரும். Now what must be the value of local oscillator so that I will get 455 kilohertz. 455 kilohertz. Now I know one thing. Whenever FLO is greater than Fs, actually the output will be FL minus A. So intermediate frequency will be what? FL minus Fs. FL minus Fs. We can get FL plus Fs also. FL plus Fs varum, but that will be removed by the band pass filter. Here also one filter will be there. Okay, at the end of the mixer, we will be having filter to allow only the intermediate frequency. Okay, to allow only this 455 kilohertz, we will have filter here. அப்போ intermediate frequency நம்ம என்ன மட்டும் எடுத்துக்கலாம், FL minus Fs, FL plus Fs ஆட்டோமேட்டிக்கா ரிமூவ் ஆயிடும் இங்க இருக்கிற ஃபில்டர்னால. இப்போ I need 455 kilohertz. I need 455 kilohertz. My station frequency is 1200K. Now what must be the local oscillator frequency? What must be the local oscillator frequency? That is 1655 kilohertz. Okay, now the problem is very simple. So if I want to receive this channel, my local oscillator frequency has to be 1655. Okay, I want to tune my receiver local oscillator to this frequency, then I can easily get this channel. So that this channel, the information at 1200 kilohertz will be converted into 455 kilohertz, then automatically it will be demodulated, then it will be given to the audio amplifier. Okay, so now this is one case. So like this, depending on whatever may be your frequency, by using this simple formula, you can easily calculate what can be your local oscillator. So just by adjusting the local oscillator frequency, you can receive any station that is in between 550 kilohertz to 1650 kilohertz using this formula. But now what is the problem here? Say, again, if you think of, say, I am telling FL local oscillator is greater than Fs, but in practical cases, Fs may be greater than local oscillator also is possible. Okay, so yes, somebody tell me, suppose if this is the case, what will be the output? Definitely Fs minus FL. Okay, simply the difference. Fs அதிகமா இருக்குனா Fs minus FL. ஏன்னா இந்த இடத்துல ஃபார்முலா பார்க்கணும், 4 காம்பினேஷன் இருக்கு. Now somebody tell me, suppose in case if Fs is greater than FL, see, I have tuned my super heterodyne receiver to this frequency 1655. Now this value is 1655. அப்போ இங்க 1200 இருந்ததுன்னா இங்க 445 வருது. But now I have taken the other condition. Okay, initially வந்து நான் Fs வந்து less than FL எடுத்தேன். Fs is less than FL. இங்க பாத்தீங்கன்னா தெரியும். But now என்ன பண்றேன்னா நான் local oscillator மாத்தல. But in case if Fs is greater than FL, ஏன்னா incoming signal நீங்க கண்ட்ரோல் பண்ண முடியாது. incomingல எது வேணாலும் வரலாம். But what is the other frequency that also will be converted as 455? Okay, if you imagine properly, if you take Fs as 2110, okay, if you take Fs as 2110, then you apply the formula here, 2110 minus FL. Okay, I am not changing the local oscillator frequency. Again, this also will produce 455 kilohertz intermediate frequency. This also will produce 455 kilohertz. That means your receiver will not know. Okay, see, you have fixed your local oscillator frequency 2655. அப்போ இந்த ரிசீவர் வந்து 1200 கிலோஹெர்ட்ஸையும் அலோவ் பண்ணோம், 2110 kilohertz என்ன பண்ணோம், அலோவ் பண்ணோம். So that is the problem here. So this frequency 2110 will be called as a image frequency of 1200. Okay, image frequency of 1200. So I'll put in terms of diagram. Say I am converting some channel that is at 1200k to the down conversion of 455 kilohertz. But by the way, what is happening? Some other channel that is around 2110k, that is also down converted to here. That is also coming here. That is also coming here. So this one we will call it as a image channel. This is image. This is actual channel. This is actual channel. So now how to remove the image channel? How to remove the image channel? அதாவது என்ன சொல்ல வரோம்னா, சூப்பர் ஹெட்டரோடைன் ரிசீவர்ல நீங்க ஒரு ஃப்ரீக்வன்சிக்கு டியூன் பண்ணீங்கன்னா ஏதோ ஒரு சிக்னலை ரிசீவ் பண்றீங்க, அதனுடைய இமேஜும் ஆட்டோமேட்டிக்கா ரிசீவ் ஆகும். அதனுடைய இமேஜும் வந்து ஆட்டோமேட்டிக்கா வந்து என்ன ஆகும், ரிசீவ் ஆகும். ஸோ what is the main aim here? We want to reject the image at the beginning itself. Okay, we want to reject the main aim here is, somehow we have identified for each channel there will be the image channel. What is the formula for that? Okay, see, for IF frequency the formula is FLO minus FS. Okay, then for image the formula is FS plus 2IF. FS plus 2IF. Okay, for any station you can calculate the image station with help of this formula. And the formula based பண்ணி தான் நானும் போட்டிருக்கேன். Based on that formula only I am getting this 2110. So now I know for each and every channel there will be the image channel. So I want to reject the image channel in the beginning itself. I want to reject the image channel in the beginning itself. ஏன்னா once image channel நீங்க allow பண்ணிட்டீங்கன்னா மிக்சர் வழியா நீங்க இங்க செப்பரேட் பண்ண முடியாது, ரெண்டும் கம்பைன் ஆயிடும். அவுட்புட் ஆஃப் த மிக்சர்ல ரெண்டுமே கம்பைன் ஆயிடும், ரெண்டு சேனலுமே. அதுக்கப்புறம் அதை செப்பரேட் பண்ணவே முடியாது. ஸோ வி வாண்ட் டு ரிஜெக்ட் த இமேஜ் சேனல் at the RF amplifier stage itself, because that's why this RF amplifier consists of band pass filter. So that band pass filter has to reject the image channel. So what is the main aim here? We want to reject image channel. We want to reject image channel. That image rejection is actually done by image rejection done by the front end system, that is RF amplifier. Image rejection is done by the band pass filter present in the RF amplifier. So இதுதான் எக்ஸாம்ல கொஸ்டின் கேட்பாங்க. சூப்பர் ஹெட்டரோடைன் ரிசீவர்ல எந்த பிளாக் இமேஜை வந்து ரிஜெக்ட் பண்ணுது அப்படின்னு. How it is rejecting the image? You can very easily you can see this RF amplifier will allow only AM band, but your image channel is going out of AM band. Image நீங்க கண்டுபிடிச்சது என்ன ஆன்சர் வந்தது? Image. This is the image channel. Image channel வந்து என்னது? 2110 kilohertz. So that is going out of the AM band. So automatically it will be removed by the front end system, that is RF amplifier and a band pass filter. But once if you allow the image channel into the mixer, you cannot remove it. Later you cannot remove it. So image channel can be rejected only by the RF amplifier. This is very important question. Okay, who will be the rejecting the image channel? RF amplifier. Front end RF amplifier will be rejecting the image channel. Then how to, again, what is the further analysis? See, image, F image is equal to Fs plus 2IF. Now why they have chosen IF as 455? Why not less than 455 or why not greater than 455? Now how to choose IF? how to choose IF? That is the next question for any communication, for any system, receiver system. How to choose IF, intermediate frequency? Anyway, for practical cases, it is fixed, but how they have fixed that? Okay. So you have to choose IF in such a way the image goes out of AM band. Choose IF in such a way image goes out of band. Okay, see what happens. Suppose if somebody is defining IF as 100 kilohertz, for example, I'm telling. Okay, this is just example. Now what will happen? Image is Fs plus 2IF. In our case, what we have taken Fs as 1200 kilohertz. Then this is 1200K. Then 2 times of IF. IF is 100K. Now what will happen? 1400K. See, that means what? This 1400K is in between the AM band. 450K. This is 1650K. That means what? Your system will be allowing 1200K and also 1400K. Okay, there may be another operator on 1400K. Okay, you are operating on 1200. Ultimately, your system will receive both station. Both the station may receive ஆகும். இப்போ எதையுமே நீங்க கேட்க முடியாது. So that is the concept of image signal. அப்போ அந்த image signal மெயினா ரிஜெக்ட் பண்ணணும்னா we have to choose IF properly. So choose IF in such a way, okay, that image signal goes out of band. Once if it goes out of band, automatically it will be rejected by the front end system itself. Then we will not have any image problem inside the super heterodyne receiver. That is the main concept of the super heterodyne receiver. Image signal reject பண்றது. அப்போ நம்ம இப்போ இந்த ஃபார்முலால பார்த்தோம்னா அப்போ once if you choose IF as I, then easily image will be rejected. With help of the formula, easily you can see, say instead of 100K, if I am choosing IF as 500K, okay, or 1000K, easily that will be going out of band. Okay, see, mostly when you choose a signal on station on low frequency, then the possibility here is image signal may be within the band. So for that, you have to choose the IF in such a way the image goes out of band. So mostly image problem எந்த சிக்னலுக்கு வரும்? லோ ஃப்ரீக்வன்சியில் இருக்கிற ஸ்டேஷனுக்கு தான் இமேஜ் ப்ராப்ளமே வரும். அதாவது என்ன சொல்ல வரேன்னா, சே ஃபார் எக்ஸாம்பிள், ஃபார் த சேம் கேஸ் ஐ ஆம் சூசிங் எஃப்எஸ் as 1500K. என்னுடைய ஸ்டேஷன் 1500 சூஸ் பண்ணோம்னா அப்போ இது ஒரு 200K வரும். இந்த எக்ஸாம்பிளுக்கே சொல்றேன். அப்போ ஆட்டோமேட்டிக்கா 1700K ஆட்டோமேட்டிக்கா அது வெளியில போயிடும். இப்போ மோஸ்ட் அஃபெக்ட் ஆகுறது என்னது? லோ ஃப்ரீக்வன்சி ஸ்டேஷன்ஸ் தான் அஃபெக்ட் ஆகுது. ஓகே, அப்போ அதனால என்ன சொல்றாங்க அப்படின்னா ஐஎஃப் வந்து நம்ம choose as high as possible, okay, to reject the image in the better way. For better image rejection, choose IF as high as possible. But if you choose IF as high as possible, what will be the problem in general? See, once if you choose IF as high as possible, you can reject the image very easily. But what is the problem? Q is equal to F0 divided by bandwidth. When you are choosing IF, anyway, after down conversion, after IF conversion, you have to use the demodulator. That demodulator will have some filter. That demodulator also will have some filter. So after conversion, I am telling, after conversion, you will be converting into 455 kilohertz, or otherwise, suppose if you are choosing IF as high as possible, you will get I value here. So that means what will happen? If you choose IF as high as possible, then Q will increase. Once if Q increases, cost of the circuit will increase. Again, that is another problem. That means design of filter becomes difficult with a very high Q. So that means there is some cap on this. So you cannot choose as high as possible. So you are, but it is somewhat in the medium range. That's why they are calling it as an intermediate frequency. So again, but if you choose IF as high as possible, you can easily reject the image. But what is the other problem? Cost of the circuit will increase. So there is some limit on that. ஓகே, இதுதான் வந்து சூப்பர் ஹெட்ரோடைன் ரிசீவர்ல மெயின் கான்செப்ட். எக்ஸாம்ல என்ன மாதிரியான கொஸ்டின் வரும்னா, கேட் ஆர் எனி அதர் எக்ஸாம், யூ ஹேவ் டு ரிமெம்பர் திஸ் ஃபார்முலா. யூ ஹேவ் டு ரிமெம்பர் திஸ் ஃபார்முலா. இதை பேஸ் பண்ணி தான் கொஸ்டின் வரும். பட் டிஃப்ரெண்ட் மாடல்ல கொஸ்டின் வரும். ஒன்றும் வரும்போது நான் வந்து சொல்றேன் அதை எப்படி சால்வ் பண்றது என்னன்றது. ஓகே, ஸோ இதான் வந்து என்னுடைய மெயின் கான்செப்ட், சூப்பர் ஹெட்ரோடைன் ரிசீவருடைய மெயின் கான்செப்ட். இந்த சூப்பர் ஹெட்ரோடைன் ரிசீவர் மெயின்லி ஃபார் ஏஎம். இது வந்து ஏஎம்க்கு. ஸோ சூப்பர் ஹெட்ரோடைன் ரிசீவர் ஏஎம்க்கு இருக்கிற போல நம்மளுக்கு எஃப்எம்க்கும் என்ன இருக்கு, சூப்பர் ஹெட்ரோடைன் ரிசீவர் இருக்கு. எஃப்எம், for FM also we are having super heterodyne receiver. Super heterodyne receiver for FM, again same diagram da, but only one simple change we have to do. Okay, FM super heterodyne receiver is equal to ordinary AM super heterodyne receiver, and then we have to use amplitude limiter. We have to use amplitude limiter. ஏன் ஆம்ப்ளிடியூட் லிமிட்டர் யூஸ் பண்றோம்னா, எஃப்எம் சூப்பர் ஹெட்ரோடைன் ரிசீவர்ல in general FM we are transmitting FM over the air. Okay, we are receiving at the receiver end. When we are receiving the FM signal at the receiver end, usually there will be the variation in the amplitude also. ஏன்னா யூஸ்வலா எஃப்எம் சிக்னல்னா frequency மட்டும் தான் வேரி ஆகணும். But when this FM signal is transmitted on the channel, so noise will be added. Okay, mostly noise will affect the amplitude part. Noise will affect the amplitude part. So what will happen at the receiver end, amplitude also will be varying, frequency also will be varying. But in general, FM means only there must be the variation in the frequency, or otherwise the receiver circuit will get confused. Okay, that means what? You cannot recover back your original message signal. So that at the super heterodyne receiver, FM receiver, we have to use amplitude limiter. This is the only difference between the AM super heterodyne receiver and then FM super heterodyne receiver. But please do not use amplitude receiver, amplitude limiter in case of AM, because in case of AM the information will be in the amplitude, but if you put the limiter, again entire information will be lost. So amplitude limiter has to be used in the FM super heterodyne receiver. It should not be used in the AM super heterodyne receiver. அது வந்து நல்லா தெரிஞ்சுக்கணும், அவ்வளவுதான். So for better image rejection, IF must be as high as possible. But for better selectivity, selectivity means you have to select a particular bandwidth. If you want to select a particular bandwidth at a particular frequency, Q must be very precise. But if the Q is very high, you cannot design the circuit easily. So circuit becomes complex, cost will increase. So that means for better selectivity, IF should be low. IF should be low. அப்போ ஒரு வேல வந்து ஐஎஃப் அதிகமாக இருக்கணுன்றோம், அனதர் வேல ஐஎஃப் கம்மியாக இருக்கணுன்றோம். ஸோ அதனால சம் மீடியம் வேல்யூவை நம்ம ஐஎஃப் வந்து சூஸ் பண்ணணும், அதுதான். அகைன் டு அவாய்ட் திஸ் ப்ராப்ளம், ஓகே, சே ஹை ஐஎஃப் ஆர் லோ ஐஎஃப், we will use double conversion technique. Okay, we will use double IF, two-stage IF. We will use two-stage IF. In case of two-stage IF, we will use high IF in the first stage, okay, and then followed by low IF. Okay, two types of mixing, two types of mixer, two types of down conversion. Okay, so once if you choose IIF, automatically image will be rejected. Then once if you reject the image, again you are down converting to another intermediate frequency, so that demodulation becomes easy. So that because demodulation will be in this end, demodulation is easy. Demodulation easy. If you put IIF at the front end, image rejection is easy. Image rejection is easy. Sometime in the exam they will ask, whenever if you are going for 2-stage IF, high IF first போடணுமா, low IF first போடணுமா? So usually high IF will be in the front end, low IF will be in the last end. அது வந்து பார்த்து